Apart from what we've seen until now, Python has also an object-oriented approach. Up to this point, we have seen one way of programming in Python, using functions and procedures. Object-oriented programming is based on classes, methods, and objects. We will see what each of these terms mean. In short, a class is a data type containing its own variables, attributes, and functions, which in object-oriented programming are called methods. A standard definition for a class would tell you that a class is like a blueprint for creating objects. An object may be regarded as an instance of a defined class, and the attribute values for a particular object define the object's state. Another term that is very used around classes is inheritance. This means that a new class may inherit all the names and functionalities from an existing class. We will talk more about inheritance in the next lecture. Now let's take this one step at a time. First, we should see how to define a class. For this, you will always use the class keyword, then type in the class name, so class. Now be careful here because the convention is to use camel case for class names. This means each word will be capitalized. And also no spaces are allowed. Actually, except the camel case rule, all the rules from function names apply to class names as well. So let's name our class simply myRouter. After the class name, in between parentheses, you should type in the word object, all lowercase, so object. This is the new style of defining classes, starting with Python version 2.2. The thing you should keep in mind here is that if a class doesn't inherit from another class, then you should always type in the word object in between parentheses when defining a class. This is a default setting and it means that this class inherits from a default class named object. I know this may seem confusing, we won't get into any more details on this topic, just don't forget to write the word object. So we have class myRouter of object, then as for any code block we've seen so far, we'll type in a colon, and then on the next row, using indentation of course, comes the class content. As with functions, on the first row after the class definition, you can type in a documentation string or docstring in between quotes to give you a hint about that class's functionality. So let's enter some text in between triple quotes. This is a class that describes a router, and close the triple quotes. Following the optional docstring, the first thing you define inside a class is the special init method, also called a class constructor. The role of init is to initialize some variables, and the method is called whenever you create a new instance of the class in which it resides. Actually, it is the first code that is executed when you create a new instance or a new object. Any special method or regular methods within a class is defined using the def keyword, as you do with regular functions. The difference is that each time you define a method inside a class, the first parameter inside parentheses is self. You have to remember to input this word as the first parameter of every class method. Self is no more than just a reference to the current instance of the class. Let's go ahead and do this the right way. So def double underscore init double underscore the self keyword. Now, after typing in self, you define any other parameters that you want to be defined and initialized whenever you create a new instance of the class. In our case, we want to define some parameters that characterize our router. So, let's say separated by comma, router name, comma, model, serial number, and iOS. Now, as with any other class or method definition, you type in a colon. Then on the next row, indented of course, you will define the object or instance attributes we need to describe the router, according to the parameters of the init method. Remember that self is used to point out that we are referring to the current instance of the class. So, self dot router name equals router name. Then self dot model equals model. Self dot serial number equals serial number. And finally self dot iOS equals iOS. So that's how you define object attributes. Now let's also define a method inside this class that will do nothing more than just print out the attributes and concatenate the model with the date. Let's define print underscore router as our method. The first parameter is self, and let's say manufacturing date. Okay. Notice that self is again inserted as the first parameter here. You should do this for every method you define inside the class. So now let's write the body of this method. Let's say print the router name is colon a space for better readability and then self.router name. Okay, I typed in those print statements just to save some time. Now let's see what's the deal with the objects we talked about so much. An object is actually an instance of the class. You can create as many objects as you want or need by simply calling the class name and entering the arguments required by the init method in between parentheses. So these arguments right here. All of them except self. This is passed by Python automatically, so don't worry about it. Now let's create our first object. Let's say router1 equals the class name, my router, and then the arguments for the init method. So let's say R1, the model 2600, some serial number, and the iOS version. Okay, now let's check router1. Indeed, we see that we have created an object right here. Now what can you do with this object? First, you can access its attributes like router name, model, serial number, or iOS. Let's see this. Router1 dot, and then you type in the attribute name. Let's say model. Okay, we got 2600, which is correct. Let's try this with iOS 12.4. Okay. Let's check the serial number. And finally, the router name. Great. What else? We can access the method we defined, print router, over here. The method borrows the attributes defined in the init method and uses them within its own block of code. So you see them right here. Also notice that we should specify a value for the manufacturing date parameter, this one, when calling this method. Again, self is invoked by Python in the background, so you shouldn't worry about it. To use the object for calling the method, we'll do the following. Router1, so the name of the object, dot, and then the function or method, better said method, name, print, underscore router, and in between parentheses, you give the argument which the function requires. So the date, let's say something in the following format. 2015 0101 enclosed by quotes. Okay, enter, and we can see that the function was executed, the method was executed correctly, and all the print statements are printing what they should. Now let's create another object and do the same operations just to prove we can create multiple objects. So let's say router2 equals the class name, my router. Then in between parentheses, let's type in some arguments. So R2 for the router name, 7200 for the model, serial number, and finally another iOS version, let's say 12.2. Okay, now let's access the object attributes, router2 dot model dot router name dot iOS, and finally dot serial number. Great, now let's also access the method within the class, so router2 dot print router and the manufacturing date as an argument, so let's say 2015 0202 as a string. Okay, great, this worked perfectly. You are also able to change an attribute of an object, like this. Type in the object name, so let's say router2.ios equals, let's say 12.3. Let's check its value now. Now it's 12.3. Notice that before it was 12.2 over here. Python also provides some functions to play around with object attributes. Let's see them. First, we have the getAttr function for getting the value of an attribute. Let's use it on the router2 object. So, getAttr. First, you enter the object name and then the attribute name. So, we got 12.3 as expected. Okay. We can also set a new value for an attribute using setAttr. So, let's say setAttr. The object is router2. The attribute is iOS and the new value 12.1. Okay, great. Now let's use the previous getAttr function to see the new value of iOS, and indeed it is 12.1. Another function you can use is hasAttr to check if an object attribute exists. Let's say we want to check if router2 has the iOS attribute defined. So attr, the object is router2, and the attribute we are looking for is iOS. Okay, this returns true because iOS indeed exists in the class. Now let's do the same thing with, I don't know, iOS2, and this returns false as expected. Finally, you can delete an attribute using the delattr function. So let's do a delattr on router2, and we want to delete the iOS. Okay, now let's check if the object still has this attribute. So we will use hasAttr, and indeed it doesn't have it anymore because it was deleted. Let's also see what is the error when trying to get a non-existent attribute. So let's say getAttr for object router2 and an attribute, let's say the same iOS because this doesn't exist anymore. Okay, so as expected, we got an attribute error. This is a new error we see in this course, saying that this instance of class myRouter has no attribute named iOS. We can also verify if an object is an instance of a particular class. This is useful, especially when you have multiple classes and objects created. Let's see it in action for object router2 and our class. So you should use isInstance router2 and the name of the class, myRouter. And we got true returned because indeed router2 is an instance of class myRouter. In short, this is how object-oriented programming, or simply OOP, works. We will not use classes and OOP to build our applications, although we could do it. It is purely a matter of choice, and to be honest, I like the classical way of programming more. Next, we'll have a look at class inheritance.